How do polymers fail from chemical attack and environmental stress cracking? Imagine a polymer as a long chain of tiny molecules woven together. These chains give polymers their strength and flexibility. But just like anything else, they can break down over time. Sometimes this happens because of chemical attack. Other times, environmental stress plays a role. Let's explore how these processes cause polymers to fail. Chemical attack happens when chemicals interact with the polymer's molecular structure. This interaction can cause the chains to break apart in a process called chain scission. When chains break, the molecular weight drops, and the material becomes weaker and more brittle. Common causes include exposure to heat and oxygen, which lead to thermal oxidation. Ultraviolet light from the sun can also cause damage by breaking chemical bonds in the polymer. Water or acids can trigger hydrolysis, where water molecules react with the polymer, weakening it further. The presence of stabilizing additives can slow this process, but if they are absent or depleted, degradation speeds up. As the molecular weight decreases, the polymer loses its ductility and becomes more prone to cracking and fracture. Environmental stress cracking is a different but related failure mode. It occurs when a polymer is under mechanical stress while exposed to certain chemicals. These chemicals act as stress cracking agents. They weaken the intermolecular forces holding the chains together, making it easier for cracks to form. Even if the stress is below the material's breaking point, cracks can still initiate. Once cracks start, they can grow slowly over time, especially if the chemical environment persists. Factors like the polymer's molecular weight and crystallinity influence its resistance. Higher molecular weight polymers with more chain entanglements tend to resist cracking better. Crystallinity also matters. Polymers with a good balance of crystalline and amorphous regions are more flexible and less prone to cracking. Reinforcements like glass fibers can help bridge cracks and prevent their growth. In practical terms, if a polymer product is exposed to harsh chemicals or mechanical stress, it's more likely to fail prematurely. For example, plastic pipes in chemical plants need to be made from high molecular weight polymers with good chemical resistance. Adding reinforcements can improve durability. Understanding these failure mechanisms helps in choosing the right material for the right environment. It also guides engineers in designing products that last longer and perform better under challenging conditions. So, whether it's chemical attack or environmental stress cracking, knowing how polymers degrade allows us to prevent failures before they happen.